couple of reminders while we're going live, when we're live. Oh, just as a side note, before I forget, yes, you do have this week off, but I am going to go live on YouTube for about 5 or 6 hours on election night. Should be fun. I don't know. I have my own predictions, and it's going to be purely numerical. I'm not going to go into any politics whatsoever. I'm not about going into political arguments on social media. Why would people do that? That's ridiculous. Instead, I'm going to be going from an objective point of view in terms of where the numbers are. For example, I'll give you an example. Let's talk about the state of Alabama. In 2016, Trump won the state of Alabama. Before the election, he was polling to win the state by 16 points. That's what he was polling at. Against Hillary Clinton, the polls showed he was going to win Alabama by 16. He won Alabama by 28, which means he outperformed that poll by 12 points. So I was just interested in the concept of, well, what if I did this state by state? What if I did this state by state? What if I went state by state by state and looked at whether or not the polls compared to the actual results and whether the candidate outperformed or underperformed the poll? And I took that flip that happened in each and every state and I applied it to the current polls that are happening. And what I have found, I'm going to put out a video about this, what I have found is that the election is much, much tighter than you would ever believe. But again, if you tune in for election night, I'm not going to be talking politics at all. I'm going to be talking numbers. Election night, I'm going to go live streaming about 5 or 6 hours. Boom! Yeah. The week that you guys have off. Yeah, I think there's a debate tonight.
Tonight?
Yeah.
Is it the president's night?
Yes. Yeah. They only do one vice presidential. But again, on my YouTube channel, I don't get into politics. I'm talking about the numbers. Yeah. No clue. Probably 9. Anyway, back to this. Couple of reminders in regards to class. Hey, remember a few months ago when I did that whole spiel about the benchmarks and I was talking about, hey guys, they want you to take this benchmark, and we told our supervisor, hey, it's the wrong benchmark. And she's like, no, just give them the benchmark. Just fold in the cheese, give them the benchmark. No, but it's the wrong benchmark. No, just give it to them. Okay, fine, we'll give it to them the benchmark. And then 2 weeks later, hey guys, you gave them the wrong benchmark? Okay. All that to say, I assigned you the benchmark this week.
Oh, yeah. It was like stuff from like a year ago.
That's what it should have been on. Yeah.
I didn't know.
The intention of the benchmark was to measure your retention of information from the previous subject. My supervisor wanted to know. Well, just remember what I've said. I think I've said this multiple times this year. Crap rolls downhill.
It just doesn't make sense.
Crap rolls downhill.
There's no berries.
Fold in the cheese.
I hate cheese.
Oh, he wasn't here for that. I told an anecdote, and you weren't here for the anecdote. So you don't get the reference, but they do. No. All right. So please make sure you're getting that benchmark done. Now, furthermore, today I am wrapping up the chapter on quadratics because for next week, I do have an assessment that I'm going to be giving you in regards to it. Now, all that to say, you will still need to know how to factor and still need to know how to do the quad formula in the next unit that we are covering. In this unit that we have been covering quadratics, parabolas, second-degree polynomials. In the next unit, we are going to be moving to cubics and quartics and quintics, higher level degree polynomials, where factoring and quadratic formula will still play a role. It just is. Cubics doesn't. Starts with a C. I know. So, let's start with this. Not necessarily. Mathematics hasn't really been that creative in regards to naming things. Let me give you an example. Let me give you an example of a linguistic historical assessment of numbers versus language. So we have words for first, second, third, fourth, correct? We have words for that. We have words to designate where things are placed in an order, right? Have you ever noticed when you get to third starts with a TH, just like the number 3. Fourth starts out with FOUR, just like the number 4. Fifth, sixth, seventh. All of those words are very similar, very connected to the number that they represent. How come first isn't oneth? How come second isn't tooth? Compared to third, fourth, fifth, sixth, etc. Those numbers, first and second, were developed independently of the names for the numbers, and they were given their own designation, but they never developed words for anything past second. It was always first, second, and then the rest. Exactly. Doesn't that make... But I'm just saying, if you think about the word third and fourth and fifth, you see what I'm saying? They reflect the number that they're naming for.
One, two, third.
Exactly. So, here's what I want to do. I want to do a deep dive on quadratics.
Yay.
Now, this deep dive on quadratics is going to take on one of your biggest fears, word problems. Now, here's the deal. For those of you in the chat, because I do see there are 2 of you in the live stream, if you want a copy of this PDF, it is in the Google Drive, or not the Google Drive, I'm sorry, in the Google Classroom live stream. I'm going to copy and paste the link that is in there for the PDF, so you can click on it and open that. And come on, paste, boom. So that link, for those of you in the live stream, should take you directly to the Google Classroom post about the PDF, and you can download the PDF. So here we are. You and a friend are playing tennis. Now, I haven't played tennis in a very long time. I know quite a bit about tennis, but not really how well to play it. Now, most of the stuff that I'm going to be doing is going to be on this particular worksheet. So I'm going to draw all of my work and all of my information, underline and everything on this worksheet. That's where we're going to focus our attention. You and a friend are playing tennis. Friend lobs the ball in the air, hitting it 3 feet above the court with an initial velocity of 40. That's where people stop reading. You back up and prepare to hit an overhead smash to win the point. Not saying all students. I'm saying most students. Most students hate word problems for a number of different reasons, mainly because they don't know what it's asking. They're confused by the wording. They wish that the word problem were just asking them to do the same thing that they've done 100 times before, so they know what they're doing and they feel a sense of accomplishment. Word problems are not going to be kind to you. Word problems are going to ask you to do different things. Word problems are going to be slightly different strategies depending on how the question's worded. We really have to understand the context of what it's asking before we can actually go into the questions. So, let's talk about tennis. I think I got a tennis ball in here. I got a baseball. You ever feel a lacrosse ball? They hurt, dude. I don't know why I have this. I think I found it one day. Anyway, I do have a tennis ball. I'll try to juggle later. Maybe it'll work. We'll see. Oh, look. I can't stop. Wait, what? I can't stop staring at the girl on your microphone cup? This one? That one?
Dude, she looked 12.
Okay, whatever. It's a game. It's a dice game called Pem Dice. I don't know. Let's talk about tennis. Now, your friend lobs the ball in the air. Ha-ha! And then hits the ball 3 feet above the court. Now, what that really means, think about where 3 feet is. 3 feet's about right here-ish. Yeah, about right here-ish. Which means that your friend is lobbing the ball up in the air and then going, ha! That's a pretty good shot.
That's pretty good.
Yeah. I was hoping it would bounce back to me. But that's what your friend is doing. You have to think about the circumstances of them hitting the ball. In tennis, you hit the ball over the court. And it comes to you, and then you hit it back, and then hit it back, and hit it back, and hit it back. Oh, he's responding again. Anyway, that's pretty good. When you're in tennis, when you do tennis, you have to give that guttural yell every time you hit the ball. You ever watch the tennis match?
Yeah.
Yeah, saying home. That's pretty good. But that's what your friend is doing. So we can actually sketch this out. We can sketch this out. And that's what I would like you guys to do on your papers as well. So let me see here. At the top of my page, I am going to create a little XY plane here, indicating the path of this ball. Now the ball starts 3 feet above the court. There's 3 feet. I'm just approximating. And the ball is going to travel in a predictable parabolic path all the way over to me, where I have my tennis racket. I can't draw tennis rackets, so I just draw them like that. Although I got to make that guy look a little bit more like me. Hold on. There, he's got a beard. I know, right? Amazing. Amazing. Oh, shh. I hear music. Are you sure? I hear lots of music. Oh, on like really low levels. Oh, yeah. Yeah. So it went away. Anyway, back to this. Now, the ball's traveling in a parabolic path. Again, I haven't even read what the questions are asking. It talks about 40 feet per second or something like that, some kind of velocity. We'll deal with that later. The point is, I'm backing up and I'm preparing to hit an overhead smash to win the point. This is the context of the situation that we are faced with. When it comes to word problems, you're going to have to recognize what the problem's asking. Sometimes you can draw a picture. And if you can, it helps to conceptualize what is going on. Let's go to part A and see what they're asking. Part A. Use the model with that equation where v sub 0 is the initial velocity, and that, again, that's where people tend to fall apart. Here's the thing. I know how high schoolers think when it comes to word problems. They stare at the problem, they try to skim for numbers, and they hope beyond hope that they can just figure it out. You can't do that for every word problem. You can't. You have to dig a little bit deeper. You have to be willing to get your hands dirty. I told you about my sandbox example, right? Yeah, you got to get your hands dirty. In this problem, yes, it's an intimidating type of equation. It's not something that you maybe have seen in this class before, but we can still deal with it. First of all, they say something about v sub 0 is the initial velocity. I'm just going to underline that. V sub 0, the little subscript, is nothing more than indicating that that's where it starts. The velocity at the moment of movement. The velocity at the beginning of movement. You guys have dealt with subscripts before. Do you know the most basic location that you guys have dealt with subscripts? The most basic mathematical outlet that you've dealt with subscripts has been this. Nope. Y equals mx plus b is the form of the linear equation. This, what I wrote up here, is the calculation of just the slope. If you want that answer, you need to go back to Finding Glory, or Finding the Glory in the Struggle, the article that I had on day 1 with the syllabus. That is my answer to that question. In mathematics, it's not that you're going to use these exact skills in life, but you are refining problem-solving skills. Refining your problem-solving skills and aptitude is what you need for life. I clearly did not say that. What I said was what you are. Now, let me ask you a question. How do you use a sword? You just you use a sword like for what it's used for killing people, right? Cool. How do you make a stronger sword? No, you do not sharpen it. You take a raw piece of metal, you beat the crap out of it after heating it. You heat it, you beat the crap out of it, you put it in water. You heat it, you beat it, you put it in water. You heat it, you beat it, you put it in water. And every time you do that, you're folding the metal in and making it stronger and stronger and stronger. You don't sharpen it, you hone it. They have what these called things, they're called whetstones, W-H-E-T. Whetstones are what actually cause the blade to be sharper and sharper, not that you're actually sharpening it. But all of that stuff has nothing to do with killing people. You want a sword that's going to be better at killing people, you would think, well, I got to practice killing people. No, you do all these other things that build up to that moment. You hone those problem-solving skills so that when you are in life, you can be faced with a problem, look into your toolbox that you have. Okay, can I solve this problem, or do I need to research how to solve this problem? Okay, maybe I can solve this problem. Let me try to solve it. You try to solve it. Maybe you do, maybe you don't. But then you can analyze after the fact how good or bad of a job that you did. That's math. That's life. That's not what I said. That is not what I said. But no, but you did say that's what I said. You just said, so you're saying. You're misinterpreting what I'm saying on purpose. I know. Anyway, back to this. Initial velocity, 40 feet per second. I never learned in school how to fix a washing machine, but I learned how to do it because I had the problem-solving skills in order to get that thing done.
So school is to learn how to solve problems.
Math is the only subject that allows you to do that. All the other subjects are worthless. Anyway, so I know the initial velocity is 40. H sub 0 is the initial height. Now, based on the picture that we drew, hopefully you can recognize that 3 feet is the initial height, the beginning height of that ball. There's 2 ways to write the answer for part A. 2 ways. One way is right here, where you replace V sub 0 completely, and you replace H sub 0 completely with the numbers that they represent. There's another way to write this, and I want you to have both written down because I want you to be able to recognize it so you're not confused if the second example shows up. Another way of writing this answer is like this. Now, H of t, again, one of those things that students look at and they immediately start panicking, is nothing more than f of x. It's f of x. It's function notation. It's the idea that you can take a number, plug it into the parentheses for the t, and then evaluate the rest of the equation at that number. For example, if the ball is at 3 feet in the air, if the ball has not been hit yet by your friend, how much time has gone by? If your friend has yet to hit the ball, how much time has gone by? Not a lot. So you have a number in mind? It's more logical than you think. How many seconds?
3.
If your friend has not hit the ball yet?
Oh, wait. So you threw it and your friend hasn't hit it yet?
Your friend is the one serving the ball. Your friend's at the top of the page waiting to hit the ball to you. Your friend is this. This is you waiting for the ball to come to you. Context of the problem. Your friend has yet to hit the ball. How much time has gone by? I'm pointing at Kelsey in the chat. Oh, she said 0. No time has gone by. Your friend hasn't hit it yet. Yes, time still moves, absolutely. But is the ball still right here? The ball is still right here. Now, hold on. What's the ordered pair? What is the ordered pair of that point on the graph? What comma what? 0, 3. Here's the thing. We need to label more on our graph. Let's go back to our graph real quick. Check this out. Zooming in. First of all, I'm going to label the bottom of this chart in seconds, and I would like you to do the same, of course, and the side of this chart in feet. This ordered pair right here is the ordered pair 0, 3. It's the ordered pair 0, 3 because no time has gone by. The ball has not begun moving. Look at what part A is saying. Part A is saying use this model to write an equation giving the height of the ball, or I'm sorry, height of the lobbed tennis ball as a function of time. If no time has gone by, then your friend has not hit the ball yet. That's what's happening. Now, eventually we're going to figure out what the heck's going over by my bearded self in that tennis racket. We'll deal with that when the time comes. But there's a certain angle that this thing is being hit at, a certain velocity that is being hit at, and it is traveling through the air over here. But if he has not hit it yet, 0 seconds have gone by. Now let me go back to the equation. If I go to this equation, other way. If I go to this equation right here, and if I decide to take the number 0 and plug it in for t, 0, 0, I ultimately get something like h of 0 is equal to 3. Because the negative 16 goes away, the 40 goes away, and you're left with 3. Yeah, at 0 seconds. That's the idea of function notation. At 0 seconds, the height is 3 feet. That's what this allows you to do. Again, we got to understand the context of the situation. People misunderstand the context all the time, and they just shout out words that they think their math teacher wants to hear. No, I want you to understand what's going on. Now I'm about to rip your heads out. Part B. What is the average rate of change of the height of over the first 2 seconds after the ball was hit? Now we're talking about the ball being hit. And we're talking about, okay, what is the average rate of change of the height of the ball? Now, I want you to think about this logically. First of all, the height of the ball is follows this path. Goes up, and then it goes down. It has a positive displacement until it reaches that maximum, and then it has a negative displacement in terms of the height. Right after the ball is hit, it has a very fast acceleration up to the maximum height, and then it slows down and then comes all the way back down like that really fast. If you know about objects moving. You got anybody in physics? What are you guys in, chemistry? Okay, whatever. You learn about that in physics. You know a bit about physics and gravity and things of that nature. But this is the kind of stuff that you be studying. So, rate of change. I don't know who taught you Algebra 1. But what's rate of change in reality? Ooh. The rate of change is nothing more than slope. Now, one might ask the question, how is that even possible? You can't have slope in a curved line. I agree. I want to show you this. Check this out. Here's the ball initially. Up and then over. I don't know where 2 seconds is going to be. Let me just estimate that 2 seconds is going to be over here. Here is 0 seconds. Here is 2 seconds. The average rate of change, or the average slope over the first 2 seconds, can be determined between those 2 points. Depending on what I say. If I say over the first 2 seconds, it's that. If I say over the first 3 seconds, maybe it's like that. If I say over the first 1 second, maybe it's like that. The slope is going to change depending on how many seconds go by and what question I'm asking. Man, if only there was an equation that we could use to calculate slope. If only there was something that I strategically left on the board to help you understand how to calculate slope. I guess we can't do it. No one's even going to stop me, because you know my game by this point. y2 minus y1 over x2 minus x1. This is how we're going to calculate slope. This is how we're going to calculate slope. Hey, what do you need to calculate slope? Okay, I still hear music though.
sensitive.
I know. Your music's too loud.
It's not head.
Where's it coming from? Oh, he just double tapped it. There he is. It's funny. I see these kids with these hoods in my other class periods or something like that, and I ask them a question, and the kid's literally sitting there. He's like, "What?" I'm like, "I'm literally looking at you, asking you a question," and you go, "What?" Like, this is when I throw the ball against the. Hold on, I can hit it. Ready? Ready? Oh, that was close, right? That was pretty close.
Try it again.
No.
No, I see, break.
I've already broken it a couple times.
Try it.
No. Anyway, back to this.
Where do you hit the fire alarm?
I need 2 ordered pairs. I need 2 ordered pairs. I have 1 ordered pair. I got the 0,3. How do I get the 2nd ordered pair? Ooh. Huh? I don't know the height.
So it would just be 2, and then y. Usually that's
If only there was a way to figure out the height of the ball at 2 seconds. If only we had some kind of numerical way of finding out the height of the ball after 2 seconds. What do we do? Yeah, plug in a 2. You plug a 2 into that equation, it gives you the height of the ball at 2 seconds. That's what that function allows you to do. If you did that correctly, if you calculate it correctly, you should get a value of 19. Meaning, at 2 seconds, the ball is 19 feet above the ground. That's what this thing does. That's what this picture does over here. This is 3 feet above the ground, 0 seconds, 3 feet. This is 2 seconds, 19 feet. That's what this thing does. And we can find the average rate of change by just plugging that junk in. Now, I'm going to go a little bit deeper into this. On the top of the fraction, I got 19 minus 3. Question. What are those 2 numbers measured in? What are those 2 numbers measured in? I need units. 19 and 3 what? What do they represent in the context of the problem? What are my units, though? On y? No, those are numbers. Those aren't units. 19 what? 3 what? You got to look back to the context of the problem. Feet. They're measured in feet. Now, that's important. That'll be very important in a moment. They're measured in feet. On the bottom of the fraction, I have 2 minus 0. What are they measured in? They're measured in seconds. That's, again, going to be very important in a moment. Ultimately, I get 8. But because of my units, it's 8 feet per second. 8 feet per second. Slope is a velocity. Slope is a velocity. It is a speed. 8 feet per second. I see you in the chat. I got you. But it's 8 feet per second, yes. This ball has a height that is constantly changing. And it is changing at a velocity of 8 feet per second on average over the first 2 seconds. Now, question. I know you guys are in chemistry, but I have to ask you this. Have they ever taught you the difference between velocity and speed? No? Hear this. Hear me now. Speed is always positive. Always positive. No matter what, speed is positive. However, velocity could be positive or negative depending on the direction that the object is moving. Yes. So as the ball is moving up, it has a positive velocity, but as the ball is moving down, it has a negative velocity. Well, no, that's what it does. It's not why does it do that, it's just that's what it does, because it'll reach a maximum point and then start coming back down. But I just wanted to tell you the difference between velocity and speed. Velocity also indicates the direction, whereas speed is just always positive. Yeah, it's one of those designations that you'll get to. Hopefully. Part C. Will the ball ever reach a height of 30 feet? Why? Which begs the question.
It's already met like its highest point.
What is its highest point? No. I did this on purpose. Check this out. I'm going to give you a little bit of a hint right here. Ready? You see this point right here, the one that I'm filling in currently? This one right here? This is 2,19. It is not the highest point. 2,20. I don't know. 2,21? No. When you plug in a 2, you get 19 back. We need this other point. We need this point, which is known as the vertex. We need the vertex. Now you're saying no. Now here's the thing. I agree with you. The answer is actually no. But the question does say why. And you need a mathematical reason as to why. Will it ever reach 30 feet? No, it will not. Can you prove it? Well, I'm going to give you the tools to get that thing done. Because here's something that we will write down into our notes in a little bit. To determine the vertex, you need the following formula. Negative b over 2a. Man, that looks familiar. That looks very familiar. Ooh, interesting. Now, it's not exactly the quad formula. It's missing something, but you're right. I've seen something like that before in the quad formula. Now, I want to be very clear. It's actually only the x value of the vertex that you're getting. But you're absolutely right. This has to do with the quad formula. The quad formula, get rid of that. The quad formula was negative b plus or minus the square root of b squared minus 4ac, the whole thing over 2a. It has that negative b over 2a. The only thing that it doesn't have is that plus or minus square root thing. I wonder if there's a reason for that. I guess we'll have to come back to that. But in the meantime, let's figure out this vertex thing. Negative b over 2a. What are a and b? Did we ever figure out what a and b were? Is there a way we can figure it out? But what is it? If only we had an equation, a quadratic equation that gave us ax squared plus bx plus c. Remember ax squared plus bx plus c? Except we don't have x's, we have t's. So it'd really be like at squared plus bt plus c. No. Fill this up. Here's what it comes down to. Fill in pen. I just threw you a pen. I just threw. Okay, you had a pencil. Good. Right here. Look right here. Look right here. There's your a value. There's your b value. It's in the equation. It would end up being negative 40 over 2 times negative 16. Question. When you guys do math and you get an answer in the calculator, do you just automatically trust that the calculator knows what it's doing? A lot of people do, yeah. You can't, though. I'll show you why. Check this out. Look at this. Look at my calculator right now. Negative 40 divided by 2 times negative 16. Ready? That is not the answer. That is not the number we're looking for. What did I do wrong?
You didn't word it correctly.
I didn't word it correctly? No, I got it. Negative b over, oh, look, I'll add in parentheses even. That's not the answer. That's not the number I need. You're overthinking. You're overthinking. You're way overthinking. No, don't overthink. Why would you overthink? Why reinvent the wheel? Look what I just did on paper. In reality, the calculation should be negative 40 over negative 32. That's what it should be. This, if you did it correctly, should give you 1.25. Is that a bird? It does sound like it's dying. Anyway, back to this. 1.25, that's what it should be. The reason why the calculator didn't give you the right answer is because you were supposed to type it in like this. Oh. No, it had nothing to do with the wording. It had everything to do with the way that students use calculators. You automatically assume that just because you typed it in a certain way, it should give you the right answer. I'm saying that you can't trust the calculator because the calculator is only as smart as the person holding it. You need to be careful. The calculator, I don't trust it as far as I can throw, which is not that far. Probably a few feet. Anyway, back to this. Question. What is this? It's the x value of the vertex, but what is it? Context. Ooh, seconds for what to happen?
When the ball will reach 30 feet.
Not when it will reach 30 feet. Close, though. You're getting closer to an answer. It's when the ball will reach its highest point. I know that bird, right? Now, how did I get 2 times negative 16? How many seconds does it? Oh, yes, how many seconds it takes to reach the highest point? She asked the question, how did you get 2 times negative 16? Boom, right here. The formula is negative b over 2a. And since my a value was negative 16, that's what has to go into the bottom of that fraction, negative b over 2a. Then I had multiplied by 2, and then I did the division in order to get that. But you're right, it's the highest, and she said it right in the chat right here. It's how many seconds it takes to reach its highest point. How many seconds it takes. This is why I spent all that time focusing on the units, because you need to recognize what this thing is doing. Now, here's my problem. 1.25 seconds is not the answer to part C that I'm looking for. I mean, it's a correct number, but it's not the correct answer. Will the ball ever reach 30 feet? The answer is no. But how do I prove that? How do I prove that? Slope has nothing to do with it. Slope just gives you an average rate of change. I'm not going to worry about that. I'm going to do something a bit more simple. Oh, there she goes. She said it in the chat. You have to plug in those seconds into the formula. Take 1.25, and I'm going to have you write this down. Take that 1.25. Someone get the door? Take that 1.25, and you plug it right back in to the equation that you had in part A. So it's negative 16 times 1.25 squared plus 40 times 1.25 plus 3. I'll catch you up in what you missed. You ready? You ready? Okay, I'm ready. Good. You said no for it ever reaching 30 feet, and I agreed with you. We had to find the vertex. We plugged in that formula. We plugged in the appropriate numbers. The numbers being 40 is the B value. Negative 16 is the A value. Where did they come from? I'll highlight it up here. They came from right here. Your A, B, and C are what I just put in boxes up top. So I plugged in those numbers, and I got 1.25. I cautioned people to be very careful with the way that you plug it into the calculator. Look how I plugged it into the calculator. Be very careful, because a lot of people would do it the first way. But then I asked the question, well, what is 1.25? And if ultimately we got to the answer, well, 1.25 is the number of seconds that it takes for the ball to reach the highest point. It's how long it takes for it to reach the highest point. You plug in the 1.25 and you get 28 feet. And that bird is really making a lot of noise outside. That's true. If it were, yeah, it'd be dead already. 28 feet. So the answer is no, max is 28 feet. That's how you prove it, though. That is how you're going to prove it. Let me go to my picture at the top of the page. I'm going to zoom into my picture. I want to fill in some more stuff because we're about to get to the crescendo of this whole thing. The vertex is 1.25, comma, 28. So now, check this out. Oh, there she is. Yeah, I was just looking what she typed in the chat. The ball starts here. Your friend smacks it. The ball goes up. It reaches a highest point of 28 feet after 1.25 seconds. Then it starts coming back down. At 2 seconds, the ball is at 19 feet above the ground, still way taller than I can reach. Believe me, I'm vertically challenged. I'm waiting for the ball to come down to me so that I can give it an overhead smash before I send it back to my friend. By the way, on your paper, you can cross out part D. I put part D. Don't know why I did that, but it's basically asking the exact same thing as part C, just differently. So I'm going to cross out part D. And then I go to part E, the crescendo of the whole day. If you plan to smash the ball when it falls to a height of 8 feet above the court, how long do you have to prepare for the shot? I'm going to read the question again, and then I'm going to go back to my picture. If you plan to smash the ball when it falls to a height of 8 feet above the court, how long do you have to prepare for the shot? This is the big question of the day. Now this whole thing is coming together. Basically, here's you. And right here is 8 feet above the court. Now, clearly, I'm not 8 feet tall, but if I put the racket up in the air and do an overhead smash, perhaps, and a little bit of a jump, if you notice my feet are not really on the ground, I'm doing a little hop there. I'm going to smash the ball 8 feet above the court. But the question is, how long do I have to prepare for the shot? When I ultimately get my answer for part E, what will it be measured in? When I ultimately get my answer for part E, what will it be measured in? It will be measured in seconds, yes. For other problems, we've had to plug in the value of t, but we don't have the value of t. We don't know how many seconds that I have to prepare for the shot. We don't know. We have to solve that. Here's what you got to do. Going back down to part E here. They gave me an equation of h equals negative 16t squared plus 40t plus 3. That is the height of the ball at any given moment. But now, bless you, I have until the ball reaches 8 feet. 8 feet in order to smash it back. This is what I have to solve. This is the equation that I have to solve. This is what the entire day has been building up to. What do I have to do? I have a quadratic that I have to solve for now. Ugh. Quadratics. Fun fact, it's not factorable, just so you know. Go ahead. What were you going to say? But I got two T's. Ooh, I got a T squared and a T there. I'm going to do something. Ready? Not there yet. I'm going to move over the 8, yes. First, I'm going to move over the 8 because, as always, I got to get one side equal to 0. Get one side equal to 0. I told you it was not factorable. And considering the fact that it's not factorable, this is one of the few stars that I have ever put into your notes. If you can't factor, or if factoring does not work, you can always count on the quad formula, as he just said. Yeah. This is what we have to do. This is what we have to do. Be very careful, but this is what we have to do. I know it's terrible. Let's do it, though. I'm going to calculate my discriminant, which is going to be 40 squared minus 4 times A times C. Be very careful. Be very, very careful with how you do this. But if you did it correctly, it should give you a value of 1280, which is a terrible discriminant, but that's what it is. It's a positive number, which means I'm going to get 2 real solutions. Let's just see what happens now. So I got to plug that junk in. Negative B plus or minus the square root of the discriminant, the whole thing over 2 times A. Hey, there it is again. We did that for the vertex, didn't we? The negative 40 over... Oh, I put 32. I'm sorry. Why did I put 32? There should be a negative 16 right there. Let me fix that. That should be a 16. There we go. But that's what I did for the vertex problem, whatever that was. I keep double checking the chat for your comments. Sorry about that. No. I sound like a lot of people. They all copy their voices after me. Is it DreamWorks? Is it DreamWorks? Is it Pixar? Are you sure it's Disney? Ice Age? No, you guys have no Disney knowledge. It definitely is not Pixar. All right, if you say so. Look what I'm about to do right here. First of all, I turned the bottom of that fraction into a negative 32. And now I run into a bit of a crossroads. Here's the thing. If this were last week, then we'd be done. Maybe we'd simplify this down a little bit, but if it were last week, we would be done. But I can't be done this time because I need an answer that makes sense in the context of the problem. I need an answer that contextually answers the question, how long do I have to prepare to make the shot? The answer is going to be measured in seconds. I have to calculate that junk out. I'm going to show you a couple different ways to do this. Question. Anybody have an Android? Anybody have an Android? No? Y'all are lame. Androids are better. You want to know why Androids are better? You can't even tell. They're in a case. You know why Androids are better? Check this out. See my phone right here? There's my phone. Ready? There's a fully functioning TI-83 graphing calculator. It is an app, a free app that you can download on Android, but you can't download an Apple. I don't know. I asked somebody the other day, hey, give me one good reason why Apples are better. And they said FaceTime. And I'm like, who am I going to FaceTime? And the guy said, you're going to FaceTime your girl. And I'm like, my wife? After 10 years of marriage, we communicate telepathically. It has other things.
No, they do, 'cause my
Yeah, it's whatever it is.
But he does a video call and a FaceTime.
I would rather talk to the person in person. The only girl I want to talk to is my wife. But I got this. I got a fully functioning TI-83 calculator. Now, the reason why I bring this up is not to make fun of your phones, although your phones are terrible. I make fun of the phones, but because you have on your Chromebooks, you know how you have the calculator extension? That's an 84, right? It's a TI-84. Now, the reason why I show you that is because I want to show you the distinction between the 84 and the 83 in the way that this is typed in. Watch this. Watch this. The way that I type this in, look what happened when I typed in the square root. What automatically happened when I typed in a square root into the 83? What happened right there? It opened up a parenthesis. Now watch the 84. Now watch the 84. Negative 40 plus the square root. Now look at that. Notice I opened up the square root. It did not give me a parenthesis. Instead, it has a little arrow thing there. I need you to be aware of this because you need how to do this properly. On the 83, I have to close the square root and then close the top of the fraction. Whereas on the 84, I just tab to the right and close the parenthesis. You have to be very careful with how you do that. I'm going to divide by negative 32. I'm going to divide by negative 32, and I'm going to get my answer. That can't be the answer. How long does it take for the ball to reach its highest point, the vertex? 1.25. And I'm waiting for the ball to come down to me. That can't be the answer. Huh. If only there was a second answer that we could find. If only there was a plus or a minus, which clearly there is. It's plus or minus, isn't it? Hey, you want to know a secret that you don't know about the graphing calculator? Watch my screen. Watch my screen up here. You ready? How did I do that? Second enter. It works for yours as well. Watch this. Second enter. Pops it right back up. So I can go back in and change this plus to a minus and get the other answer. No, I literally just go over the plus sign and overwrite it. I overwrite it by literally typing in a minus sign. That's all it is. You got to know how to use your calculators. I know, you really should. In Algebra 1, they should really teach you. Anyway, back to this. Check this out. You got two answers. You got two answers, as you typically do. You got an answer of 0.132, and you got an answer of 2.37, both measured in seconds. Now, in the context of the problem, which one is clearly the answer? Yes, but I have a better question for you. 2.37 is clearly the answer. Clearly the answer. According to all the pictures that I've drawn, it should be 2.37. Because if I look at this picture right here, the vertex is at 1.25. The ball travels to 2 seconds and 19 feet. And by the time it comes down to me, this is approximately 2.37 seconds. How come I got that other answer? What was it, 0.13 something, 0.132? Where did that come from? That came from somewhere. 2.37 is indeed the answer, and you can circle that, 2.37 seconds all day long. But where did the second answer come from? How many feet off the ground is the ball when it starts? Okay. And then it travels up, and then it travels down, and it comes to me. Over here, at 8 feet, is 2.37 seconds. Isn't this also 8 feet? The ball will actually reach 8 feet twice. It'll reach 8 feet once on the way up, and it will reach 8 feet a second time on the way down. The one on the way down is what we needed because it answers the question in context, 2.37 seconds. That's how long we have to prepare. But I just wanted you to recognize that that other answer still counts as 8 feet off the ground. It's just a few fraction of a seconds after your friend hits the ball. Now, do you actually return it correctly? I don't know. It depends. But that's not the question that's being faced. Okay. Here's what I want to do to wrap up. I have a couple pieces of information that I want you to write into your notes. So, if you do not already have them out, I'm going to need those notebooks out and open. This is what we're going to do to wrap up. I know. I had the door open, it didn't help. I had the window open, it didn't help. All we did was hear that bird until somebody killed it. I know, right? All right. I'm going to call this quad formula continued. Yeah, it's a continuation. It's like a threequel. First of all, the vertex formula to get the x value of the vertex, I wanted to make sure that we had this written down into our notes, is the calculation of negative b over 2a. It is very similar to the quad formula, which at this point, hopefully you have memorized. Negative b plus or minus the square root of b squared minus 4ac over 2a. Now, we said it was very similar before. But there was a part that was missing, and it was the b squared minus 4ac underneath the square root. In fact, you can see it right here. I'll just kind of like cross that out up here. Look, it's like it went away. What would cause it to go away? What would cause that square root to just poof, disappear? Adding or subtracting. You're adding the square root or you're subtracting the square root. What number, if you added or subtracted, would not do anything? No, would not do anything. 0. If you added 0, subtracted 0. When would that square root of your discriminant be 0? When would the b squared minus 4ac be equal to 0? It's something we covered a couple weeks ago. This whole thing. If that becomes 0, how many solutions do you have? No. You have one solution. It's when your vertex and your x-intercept are the same thing. Oh, she said it in the chat. She said when there's one real answer. Yeah. I'm just waving at her. Anyway, sorry I keep missing the chat. I really should have it open in multiple locations. Anyway, back to this. Now, there are multiple forms of an equation that I want to show you that I just want you to have written down. I want you to be able to recognize these. There's 3 different ways you can write a quadratic. One way, actually 2 of the ways you already know. 2 of the ways you already know, it's just that you don't know that you know them. First of all, there's standard form. This form you know. This is called standard form. I want you to recognize the fact that that thing is called standard form. If they ever refer to standard form, that is the form that they're talking about. Something we've been doing for weeks. They also have another form called vertex form. This is one that you may not be as familiar with. This one that you're not as familiar with looks like this, and I want to talk about it a little bit more. In this form, there's a lot of similarities. It still has an x, It still has a y. It still has an a. And that a is the same a as before. What are the only things you're not as familiar with? What parts are you like, wait, what are those? The H and the K. The H and the K are your vertex. Now I'm going to show you something on Desmos in a few moments that's going to kind of drive this point home, but we'll get there in a minute. I want you to be familiar with that. Finally, they have something called intercept form. Now, this is a form that you have seen before a lot. You have seen intercept form a lot. You just don't know it. Intercept form looks like this. What does that kind of look like to you? Because these are all quadratics. But have you ever seen a quadratic turn into something like this? Oh, that's a lie. Yeah? When? In the past few weeks. This is also called factored form. When you factor a quadratic, you get those parentheses. And you set that thing up as a parenthesis times a parenthesis. That's what factored form is. And when you put it into factored form, you can solve it. And when you solve it, what is another word for the solution of a quadratic? What is another word for the solution of a quadratic? There were 4 terms. We said solutions, zeros. And roots, but I want to focus on x-intercepts. That's the reason why they call it intercept form, is because the factored form allows you to get your x-intercepts. Now, let me show you some on Desmos real quick. Japan. Desmos. I got plenty of time. Kidding me? I know what I'm doing. Check this out. You see that quadratic written in red? That is the quadratic y equals x squared plus 2x minus 8. But look at it in all of its wonderful glory. I'm about to put another quadratic up there, but this quadratic, I believe, will be in blue. Come on, you. There it is. What do you notice about this blue quadratic compared to the red quadratic? What do you notice? Kind of. Hold on. Let me. I'm gonna mute the blue one. Ready? I just muted it. They're on top of each other. They're the exact same graph. It's just that the first one is in standard form and the second one is in vertex form. And watch this. Look at the green one. It's the exact same thing, except the green one is in intercept form. All 3 of these equations are exactly the same, except one is standard, one is vertex, one is intercept. It's just manipulating the way the equation looks. Please do not forget the benchmark that you have due for me. And as I said, we are aiming for a major assessment next week. We're going to be wrapping up this unit. Bell's going to ring, but I will still take your question. Go ahead. Thursday of next week, correct. The assessment would not be in class, though. I know. Isn't that wonderful? Yes. My assessments, as I have intended this